Let's talk about here last the geometric sequence. Arithmetic are equally spaced. Geometric, their distinguishing characteristic is the ratio of the terms. The ratio of the terms of a geometric sequence are constant. Meaning the ratio of terms is the same throughout. For example, 3, 6, 12, 24, 48, etc., etc., etc. I'm looking at the ratio of terms, which what do I mean by that? Divide the terms. So I take 6 divided by 3, that's 2. 12 divided by 6, that's 2. 24 divided by 12, that's 2. And 48 divided by 24 is 2. So the ratio of terms, or another way you could look at it is multiply by 2, multiply by 2. Yeah, I'm multiplying by the same thing each time to get the next term. But that translates into it being a ratio of terms. So obviously the ratio is going to be important. In this case, R is 2. All right, so that's geometric. If it has a common ratio, it's called a geometric sequence, and R is the common ratio. Now, what can happen? Well, here's a couple of things on this one. 90, negative 30, 10, negative 10 thirds, 10 ninths. This too is a geometric sequence, so one note here is note the alternating terms. So you can have alternating signs in a geometric sequence. Here's what that's going to mean. A couple of things here. Now notice here, these are also sort of decreasing. I mean, it's because of the alternating thing, but again, be aware that your ratio, your R, is you take a term and divide that by the previous term. Because if you go the other way, you get something else. So take the term divided by the previous term. So it's negative 30 divided by 90, not the other way around. You may want to go the other way around, but it's the term divided by the previous, just like we did up here. What does that give me? Well, simplify, that's negative 1/3. 10 divided by negative 30 is also negative 1/3. And then even if you do these, negative 10 thirds divided by 10, which you might be thinking, well, what is that? But if you remember, divided by, if you got fractions divided, think reciprocal. So negative 10 thirds divided by 10 means negative 10 thirds divided by the reciprocal, or times the reciprocal of 10, 1/10. So the 10's do cancel, so you get negative 1/3. So anyway, what's the ratio here? Negative 1/3. So keep that in mind. You take a term divided by the previous term. And so sometimes you get a negative ratio, and also note there, sometimes you also get a ratio that's less than 1, if you will. Okay? All right. So with that in mind, are these next few here geometric? Sequences. Number 1, 500, 250, 125, 62.5, and of course, if it is geometric, I will want the ratio. Is that one geometric? Okay. Yes, it is. What is R? 2? Not quite. R is 1/2, yes. Because remember, you're going 250 divided by 500. And if you do that, that gets 0.5 or a half. 125 divided by 250, that also gives me 0.5. And 62.5 divided by 125 also gives me 0.5. So yeah, the ratio is 0.5 or a half. Yeah, it's really easy to say there are 2 but they are halving instead of doubling, if you will. Okay? Well, we've been trying this one several times now. Let's see if it's a geometric. 1, 4 are squares. 1, 4, 9, 16, 2, 25. 4 divided by 1 is 4. 9 divided by 4, well, it's 2.25. And that's enough to say, nope, it's not geometric either, okay? Don't have a common ratio. It's not arithmetic. The squares aren't. And it's not geometric either. Is this one geometric? A sub n equals 5 times 4 to the nth. Well, might be a good idea to write these out, a few anyway. What's the first term? First term would be 5 times 4 to the first. 5 times 4 to the first, that's 20. Second term would be 5 times 4 squared. That's 5 times 16, which is 80, isn't it? Second term would be 5 times 4 cubed, which is 5 times 64, which is 320. And fourth term would be 5 times 4 fourth, which is 1280. I think that's sufficient enough. What do you think? Geometric? Yep, it is geometric, isn't it? It is geometric, and the ratio is, what's the ratio? 4. Yeah, you divide term by previous term, you get 4. Okay? All right, well, let me just go with that for just a second. So here is what a geometric sequence looks like if you write it out sort of in an equation type setting. And do you notice what type of equation this is? Well, the n, notice where it is. The n is in the power. So if the n is in the power, that's called an exponential expression. Covered those a couple of chapters ago, but yeah. If you have an exponential expression, then that expression generates a geometric sequence. Okay? So geometric sequences are exponential. Power contains the exponent. Power contains variable. Okay, the variable is in the power. That's what that means. You've got the variable in the power. That's an exponential, and that's geometric. Now the other point is, notice, what was my ratio? 4. Do you notice 4 in the equation here? That's not coincidence. Turns out the ratio, the R, is the base of your exponential expression. Not the number in front. It's the base of whatever expression it is. For example, if I have a sub n equals 8 times, parentheses, negative 3/4 to the n plus 1. Now this has a plus 1 in the power there, but that's still exponential, isn't it? That is an exponential expression because the variable's in the exponent. Okay, so that's exponential. So this means this is geometric. If we wrote out the terms, we'd see a geometric sequence. And the R, what's the R? Negative 3/4. Yeah, here the base is a fraction and it's negative, so whatever that base is, yeah, that's going to be your ratio. All right. One last thing on these. Is that okay? All right, just like with, just as with arithmetic, there is a formula for summing up in terms of a geometric sequence. Let's call this the geometric series formula, or one of them anyway. It goes like this. If you have a geometric series, in other words, the terms are geometrically related there, then S sub n equals this. It's a sub 1 times 1 minus r to the n over 1 minus r. A little more complicated formula, but guess what it means? This is, again, the first term. R is your ratio, and n is the number of terms. So let's look at applying that formula to 1 here. So this is the sum of the n terms of a geometric series. Take the first term and then multiply it by this lovely expression there. All right, so let's take a look at this. So what's sum n equals 1 to 10, the first 10 terms of this right here, 4 times 2 to the n. Is that geometric? Yes, it is. It's exponential, so it's geometric. So that kicks in then this formula. So I can use this formula for a geometric one. So that says instead of having to add up all 10 terms there, what I can do is take the first term, which the first term would be 4 times 2, 8. You added. Okay, 4 times 2 is 8. So the first term is 8. Times that by 1 minus what's the ratio? Yeah, r is 2 because it's the base. Always the base there. So r is 2. I've got 1 to 10, so that's 10 terms. And then divide by 1 minus just r, so it'll be 1 minus 2. So that's going to be 8 times 1 minus 2 to the 10th is 1024. Divide that by negative 1 minus 2, so it's 8 times negative 1023 divided by negative 1, which is basically 8 times 1023. Which is 8,184. Do one more of those. If I take the sum n equals 0 to 12 of 6 times negative 2/3 to the nth. Also geometric, because it's exponential. And so I can apply the formula S sub n, a1 times 1 minus r to the n, 1 minus r. Okay, how does this one start? Well, the first term, well, that's one point here. The first term is not n equals 1, it's n equals 0, isn't it? So I plug in n equals 0 there for the first term, and I get what? Well, I get negative 2/3 to the 0, but that's really nice because what's anything to the 0? 1. So that's 6 times 1, so that's 6. So that part of it's nice anyway. All right, then I have 1 minus the ratio. Ratio is negative 2/3, so I go negative 2/3. Raise that to the number of terms there are. Well, 0 to 12 is 13 terms. And then divide that by 1 minus r, which which again r is negative 2/3. That's the r. The base of the exponential thing there, okay? And so here's what I'd recommend on that. This, do the power first. Negative 2/3 to the 13th power. And I'd use the parentheses. And it's a negative 0.005. 138, let's say. Then also, it's going to happen there too, but when I do 1 minus negative 2/3, that's going to be a plus 2/3, isn't it? So it's going to be 1 plus 2/3, which is be 1 point, if you do decimal, 1.666666. So this up here also is plus, so that's going to be 6 times, it'd be 1.005138. So this is not going to be a nice, pretty number. Divided by 1.666. That's what you got. Times it by 6. See if we get it. See what I get here. 6 times 1.005138 divided by 1 point, how many sixes do you feel like doing there? So it's about 3.618. 3 decimal places, let's say 3.618. So some of them won't come out just really, really nice.